Alrighty folks, just going to quickly solve 15A from 3.1 homework. Didn't get a chance to the other day or yesterday in class or today in class, depending when you're listening to this. Anyways, the question is asking you in the summer for 15A how long that overhang needs to be. In other words, this distance here, how long this overhang needs to be so that the sun hits, the shadow rather, falls right to the ground. So the sun doesn't actually hit the wall at all. And so basically this is the triangle that we're solving here, okay? And if you understand that this angle here, which is 73 degrees, is the same as that one there, okay? Because this is a parallel line, that's a parallel line there. And so these are alternate interior angles, they're the same. So this is 73 degrees, this is 20 feet. I just need to solve for x, that short side there, okay? So that is the adjacent side. I know the opposite side is 20, so I'll set up my ratio like this. 10 of 73 is equal to the opposite side divided by the adjacent side, so 20 divided by x. And then x is simply going to be 20 divided by 10, 73. And you can do that on your calculator. And you get x is equal to 6.1 feet, so about a 6-foot overhang. Okay, and that'll stop the sun from hitting the wall at all in the summer. During the winter, for 15B, it looks a little different. So let's look at that drawing. Okay, so this is what 15B is looking at, and you're trying to find here the height of the wall that will be in direct sunlight, in other words, this portion here. Okay, now you can't really find that directly because this is a 90-degree angle here, but I don't know this measurement here, so I can't find that side directly. So I'm going to have to find it indirectly by looking at the smaller triangle that I'm going to draw for you in red, this little guy right here. Okay, so that triangle there I can solve because I know already that this is a 6.1 foot overhang from 15A. And then I'm going to have to find whatever x is and then subtract that from 20 to figure out what the blue section of the wall is where the light hits it. So let me draw a bigger version of that triangle here for you. Okay, and then the angle that we know, just like the last time, this is 28 degrees because it is an alternate interior angle to this angle over here. So these two lines are parallel. The line that cuts across here is like a transversal, so the alternate interior angles are equal. So I can solve for x using, again, tangent. Tangent of 28 degrees is equal to x over 6.1. Okay, and then to solve that, you simply have to multiply both sides by 6.1, and you get x. Okay, and the answer then is 3.25 feet. But that's not your final answer. That's just what this is up here. The whole thing is 20 feet, which means that this has to be 16.75 feet. So that's exposed. The 3 1/4 is hidden by shadow. The other 16 3/4 feet of wall is exposed to the sun. So that's how you solve question number 15. If you still have questions about that one, please come and see me. Otherwise, good luck getting that homework done. I mean, please get the homework done. I'm sure you don't need luck to do it, but I hope you can. And we'll talk more about that tomorrow. You may, and this is just where you get a little inside information for watching the video, there may, in other words, there will be a quiz tomorrow on 3.1 and 3.2. I know it's an unannounced quiz, but I'm telling you because you took the time to listen. Congratulations.